Now this one is a little tricky question from cubes. Okay, so first pause the video, read the entire question carefully as we always do, then unpause it and then come back. So it says two people A and B were bored, so they decided to play a game. They had 27 identical dice, where each face a dice had a distinct number written on it out of 1, 2, 3, 4, 5, 6. Those numbers are written in such a way that the sum of the numbers on every opposite face is 7. So 1, 6, 2, 5, 3, 4, something like that. Okay. They found a large cube of size 3 by 3 by 3, that is using the 27 identical cubes. The dice in the cube are arranged in such a way that the cube so formed has all the properties of these dice, that is on each face of the cube, only same digit of the dice. Okay, so basically what it means is the orientation of all 27 dice is going to be the same. So if I put one of them as 1 on this side, 6 on this side, then the behind one will also have exactly same pattern, 1, 6. So if I have 2 and 5 here, for the piche wala also we have 2 and 5 here. If I have 3 at the top and 4 at the bottom, for the behind one also we have 3 at the top and 4 at the bottom, and so on. So all 27 small cubes have exactly the same orientation. Then only this is possible. So that when the larger cube is formed, you see that we have 1 on each small cube. We have 6 on each small cube here. We have 3 on each of the small cube here. We have 4 on each of the bottom of each of the cubes there. Or we have 2 on this side on each one of them, and 5 we have on this side on each one of them. So basically that's how it is. The face on which all visible right. So basically the rules of this game will be as follows. So these are the set of rules. Each of the two men takes out a dice only one by one from any visible face or edge or corner of the cube. When one takes out a dice, faces of its adjacent dice, which were earlier covered, will now become uncovered and number written on them will be visible. This is a very interesting information, very beautiful. You will be able to see that this is a very standard statement. The meaning is something that is very trivial. Okay. Now, amount equivalent to the sum of the numbers written on these recently uncovered. So the numbers that become uncovered, that will be paid by the other guy to the person who has taken out the dice. Example, if A takes out a dice from the corner, faces of 3 of its adjacent dice now become uncovered. The sum of the numbers of these faces is the amount paid by B to A. What a beautiful situation. I'll explain this one very in detail. Okay. Now these are the questions that we have. There are different situations. If A takes out a dice from all 8 corners, then what is the total amount B should pay to A? This one and this one. So first let's do one thing. Let's try to understand that faces of this, the sum of the numbers. Okay. First of all, let's understand this, what it means. If I put one cube like this, please watch it very, very carefully. If I put 1 here, then on the back we have 6. If I put 2 here, then on this left side we have 5. If I put 3 on the top, we have 4 on the bottom. What you need to understand is the cube by the side of it will also have exactly the same orientation, isn't it? The next cube or the cube behind or the cube below, I'll just draw it. The next cube is just that in the actual situation they are attached, they're touching each other. If you separate them, exactly the same thing will be visible, isn't it? 6 here, okay, 5 here, and 4 at the bottom. Whatever is the situation, it is exactly the same. If I draw another one here, I'll draw a little smaller because I have that much space only. The point is, the orientation is exactly the same. If I put one above this, that also has the same orientation. Okay. If I draw something below this, so for all the cubes, this is exactly how it is going to happen. What you only need to identify what is going to be exposed when you remove one of them. Now to understand that, I'll draw another situation wherein I have taken all 27 into consideration. So we have to draw 3 by 3 by 3. That means we need to put 2 cuts, right? We need to put 2 cuts. So 1, 2, 1, 2, 1, 2, 1, 2, right? You see, each one of these, so how many are these? These are 27 cubes. Each one of these has exactly the same orientation like this one. That's what it exactly means. I'll just write 1 here, 2 here, 3 here. Now, it's very important to understand, what if I remove a corner one? If a cube at corner, I'll write removed here, okay, at corner is removed, what will be the new exposed numbers? Think about that. If you remove from the corner, see what was already exposed? Already exposed was 1, 2, 3. So when you remove it, exactly same thing will be visible. You know, for the back one will be visible. Okay. For this side, the left side, 2 will be visible. And for the bottom one, you know, the cube below this, the top of this will also be 3. Try to understand that. The cube behind this, I'm removing this corner one. So cube behind this is going to have 1 in the front. The cube on the left of this is going to have 2 on the front. Right? So it's very simple to understand. Whatever you are removing, exactly the same numbers are going to be exposed. So cube at the corner, same numbers are going to be exposed. Okay. Acha. And how many numbers? 3 numbers. See, at the corner only 3 numbers were originally exposed. So the new exposed numbers will also be 3. Okay. If I remove something from edge, cube at edge, then what happens? So what I'll do is I'll write 1 here, 2 here. The top of this is 3 and the bottom is 4. This is the edge one. If I remove this one, how many are visible right now? 1, 2. So 2 faces are visible. So when you remove this, 4 new surfaces will be visible. What will be those surfaces? Think about that. Okay. If you remove this edge one, for the back one will be visible. For the left one, 2 will be visible. Right? So that is there for sure. What was not visible in this case? For this, the ones that were not visible were 3, 4, 5, 6. But out of that, what will be the new uncovered numbers? Let's check that. So for example, cube at edge, if I'm taking example as 1, 2 was exposed, the new exposed numbers will be, for the back one, 1, for the left one, 2. For the top one, you see here it is 3, so here exposed number will become 4. Okay, right? Now here, the top number is 3. So 1, 2, 4, 3 will become visible. What is not visible? You can check it like this. For 1, 6 is not visible. For 2, 5 is not visible. So 1 and 2 are visible. So when I'm taking out the cube which has 1 and 2, opposite of 1, that is 6, will not be visible. Opposite of 2, that is 5, will not be visible. Rest everything will be visible. Okay, right. What if I take out something from the face? If I take out something from the face, this one. So originally this had only one surface or only one face visible, right? Let me take here. Okay, don't forget that this has only one face originally exposed. Okay, so if I take out a cube from face, Originally there was only one number exposed. So the new numbers exposed will be, just apply the same logic. Originally one was exposed. So when I remove this, the cube at the back of this will have 1 as visible. Now this back of 1 in the same cube, there is 6. 6 will not be visible. For 1, the pair is 6. 6 will not be visible. All the other numbers will be visible. Think about that. 1, 2, 3, 4, 5. Because when you take out this, there's only one surface. So when it is removed, inside in that hollow space, there will be 5 cubes that will get exposed. How come? 4 on each of the sides and 1 at the back. On the cube that is exactly behind this, 1 will be visible in the front and 4 numbers here. Those 4 numbers will be 2, 5, 2, 5 and 3, 4. 6 was at the back of this. So for the other one also 6 will be at the back and that will not be visible. So one thing that is easier to remember, that for the corner ones, it is exactly the same 3 numbers that will be visible. Okay. For the edge and for the face, for both of them, whatever number was originally visible, those numbers will definitely be visible, and their pair for making 7 as the sum for opposite surfaces will not come. So for 1 and 2, 1 and 2 is there. For 1 the pair is 6 and for 2 the pair is 5. So 6 and 5 will not come, 1, 2, 4, 3 will come. Similarly, when I have one face, it has one number, say number 1. So the new numbers will be 1 itself, and opposite to 1 usually there is 6. So that will not come, all the others will come. So if I take out something from here, the number that has 3. So if I take out 3, if I take this 3, the exposed numbers will be this 3 itself, and the pair of 3 to make 7 is 4. So 4 will not come, all the others will come. 1, 2, 5, 6. Right? And so on. Okay, so this is the basic explanation. Now let's look at the questions. What does it say? So it says, so now we can do it. See, the whole point is, for such questions, the idea of visualization has to be really very, very clear. Please do this on your own. If it doesn't bother you, get 27 dices, do it for once, and if you do it for 27 dices, it will work for 125 dices also. It will work for 216 dices also. That's the beauty part of it. So do not hesitate in doing that, but you will not need it if you just put a little effort in imagining the same cubes. You have to understand that every cube has exactly the same orientation. Okay, you have to see which one is going to be visible and so on and so forth. Okay, so first question, if A takes out a dice from all 8 corners, then what is the total amount we should pay to A? Now here we need to understand that the opposite surfaces are 1, 6, 2, 5 and 3, 4. These are the opposite surfaces, right? So now for any corner cube, the exposed surfaces can be what? The exposed surfaces can be one number from here, one number from here, one number from here, right? So there are 8 possibilities. So 2 possibilities here, 2 possibilities here, 2 possibilities here. So 2 into 2 into 2, that is 8 combinations. And the combinations are symmetric. Okay. So for example, just to show, I'll show all those 8 combinations. 1, 2, 3. So I'm trying to say that if I take out a cube, the exposed surfaces can be 1, 2, 3 like this. But this is this corner. The corner behind, okay, 1 will not be visible. Okay, 6 will be visible, and so on and so forth. So you can directly do it from here. The possibilities will be 1, 2, 3 at corner, or 1, 2, 4, or 1, 5, 3, or 1, 5, 4, or 6, 2, 3. These are at corners, okay? 6, 2, 3, or 6, 2, 4, or 6, 5, 3, or 6, 5, 4. I'll go back to that. You see, For this cube, 1, 2, 3 is visible, but the cube which is exactly at this point, you see 3 will be visible here, 2 will be visible here, the backside will be 6. So the combination is 1, 2, 3 and 6, 2, 3, right? Similarly, this corner, 3 will be visible, 1 will be visible, and this side will be 5. So 1, 3, 5. For this corner, 3 is here, back to 1 there will be 6, and back to 2 there will be 5. So 3, 5, 6 will be visible. For this corner, 1 is here, this is 2, so back to this will be 5. Okay, and bottom opposite to 3 will be 4. For this cube, here it is 1, here it is 2. The top side is 3, so the bottom side will be 4. For this corner, here it is 2, back to 1 it will be 6, and bottom to 3 will be 4. So 2, 6, 4. And one possibility which is not visible on the screen, but I'll just show it by dotted lines. Okay, there will be one at the back here, at the, if I have this size, then this corner is not visible. Okay, so that will have a combination. The bottom would be back, low, corner will be, the bottom will be 4, okay, and the exposed surface opposite 2 will be 5, and opposite 1 will be 6. So you can see these are all 8 combinations that I had written there, right? Now for the corner ones, it is exactly the same numbers that get exposed. For the corner ones, exactly the same number that get exposed. So if these are the numbers, the same thing will be get exposed. So the amount that is going to be paid, that is simply equal to the sum of all these numbers. So if these are the original numbers, the same thing will be exposed, right? So the answer will be the sum of all this. Now look at this carefully. There are total 8 combinations, and in each one of them 3 numbers are appearing. So total appearances, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 12, 24 appearances. And these appearances are symmetric. Every digit has to get equal chance. There are 6 digits. So divide by 6. Every digit appear 4 times. Okay, you can actually count that also. So the answer would be 4 times 1 plus 2 plus 3 plus 4 plus 5 plus 6. And that is 4 into, this is 21. So 84 rupees. That is such a beautiful question. Okay. So please repeat this solution. This is not very difficult, and whatever I have said, it may seem a little difficult for the first time, but if you just repeat it once with a slow motion, try to imagine, try to draw the cubes by the side. It's very important to understand. Try to draw the cube by the right side, by the left side, the above one, the below one, and the back one. You will be able to see all the exposed surfaces and all. Okay. Now, before I take the second one, let's take the third one. It looks smaller. Okay. If A takes out a dice, then what is the smallest possible amount? See, the smallest possible amount from a corner. Smallest possible will be when less surfaces are visible. Less surfaces are visible when we take out from corner. From corner there are 3 exposed. Okay. So 3 numbers are exposed. From edge, 2 are exposed. So 4 new numbers come. Okay. From face, only 1 was exposed originally, so 5 new surfaces come. Okay, so what should I do? I should focus on less surfaces. So for less surfaces, what should I do? So for smallest, I should go for corner. And for corner, if I want least amount or smallest possible amount to pay, original exposed should be the smallest one. So I'll take this cube in which 1, 2 and 3 was visible. So the new numbers will also be 1, 2, 3. So the smallest amount is 1 plus 2 plus 3, that is 6 rupees. Right. Okay, now the second question, read carefully first. If A takes out a dice and then B takes out a dice in such a way that the number of faces got uncovered is different for both of them. Okay, this is different for both of them. Then what is the maximum possible difference between the amounts they need to pay each other? Okay, different for both of them. Right. We want to find the maximum possible difference, that is 1 point. But we also want to make sure that each one has to pay maximum possible amount. Right. So for the maximum possible amount, what you should do is maximum exposure in the later stage, maximum exposure after removal. That means A, if he has got a chance, he should pick up from the face. So that original exposure was only one face and new exposure will be 5 faces. And if he wants to get the maximum amount, what should be the maximum amount? He should leave the smallest value. So he should actually withdraw from the surface where 6 was visible, the back side. Because 1 is visible in the front. So if you take out 1, you get 1. So if you take out 6, you get 6 and the other number. So what happens for A, let him pick up a number from that face where 6 was visible. So he'll get this original was 6. So the new numbers will be, remember what was that? 6 will definitely come, and opposite to 6, 1 will not come, all the other numbers will come. So his total amount is going to be 2, 3, 4, 5, 6, 11, 15, 18, 20 rupees for B. Now the number of faces that their faces got uncovered is different. Now for A, we have taken 5 uncovered faces. So I cannot take for B 5 uncovered, but I can take 4 and 3. But for maximum amount, let's take 4 uncovered. And to get 4 uncovered, he should get it from where? He should get it from an edge. He should get it from an edge. Okay. He should get it, the one from edge, right? So this one, he should get it from this one. And for maximum amount, take such a situation where you get original numbers exposed as maximum, so 6 and 5. So if his original numbers are 6 and 5, and if he's taking out from face, the new numbers will be this 6 and 5. And the pair of 6, 1 will not come. Pair of 5, 2 will not come. Opposite of 6, 1. Opposite of 5, 2 will not come. Other numbers will come. So 3 and 4 will come. So the total amount for B will be 11 and 3, 14 and 4, 18 rupees. These are the maximum possible amounts for A and B. The difference between them is 20 minus 18. That is 2 rupees. Right? So this is, it looks like a difficult question, but it's actually not. Believe it and then work on it. Okay? Because this is a standard trivial situation. Why trivial situation? The most important part was this one. How can the combinations be made? So try to visualize the corner ones a little more in detail. The others will follow suit. Okay? Right. If there is still any trouble, you can always get back. One of the very important aspect of CAT coaching at iQuanta is application classes. Live conceptual classes, these are always there, definitely. And this is the general structure of the program that we do. Just take a look at it, take benefit of it. If you want to know more about all these things, all these courses, visit iQuanta website, call on the number, get in touch with us. We'll try to help you. Thank you.